Okay, so my name is Alexandar. Um, my career started out as a support engineer, then I became a consultant, and now I'm this DevSecOps creature. I'm saying that because DevSecOps actually has a lot of different, it's an interdisciplinary field, which has a lot of roles in itself, such as engineering, but also architecture, a bit of operations development, as the name implies. Yeah, I finished the implementing DevSecOps Linux course, which was great. But the funny thing is that it's so this field of security is so dynamic that even it contained some stuff that were already obsolete. I know Bash, Python. I have experience, going through writing an application, going through the change management process at IBM, and publishing it to production environment. And yeah, that's how I know a little bit about from the developer side of things. I have varied experience in maybe a unique blend of different organizations, private, government, non-government, and really there are only, I would say, two types of organizations. So there are executors and there are innovators. The difference being in the culture. But we're going to mention that a little bit later during the presentation. Something about me, I have a wife and a daughter who are in this hall with us. Обичате Victoria, so that is for the record. Okay, so the topics, you can read them faster than I can say them, but basically we're going to start off really slow and really basic, but then we're going to advance very fast and deep dive into this whole area. So a bit of context. Please raise your hand if you think that an application is a product. Okay, we have 1, 2. Okay, if you think if you think if it's a service, someone thinks that it could be both. Yep. Okay. Okay. That's great. Yeah. So an application can be many things. It can even and when we say a product, it can even be a physical product. But that's getting very complicated because then we need to consider some safety issues, etc. So we're not going to go there. We're just going to focus on the software for this presentation. But I would like to start actually to go back one step and start from the very beginning, and that's actually an application is an agreement. Because an application does not usually exist in a vacuum. Yeah, sure, the creator can use their own application and never share them, but this is not what we're speaking about. We're speaking about even if I use an application which is open source, it's free, there is still this license which is provided as is without warranty of any kind. So it's an agreement, always. Yeah, we're going to go for we're going to examine the open source applications a bit later in this talk. On the other side, there's the commercial applications which have different business models, and we need to be aware of those because, like, if we are tasked with protecting them. So, yeah, traditionally in one-time transaction. Now it's the more modern approach is pay as you use it, or as we also know it as a service, and then there is the subscription. But really, maybe what most people would expect from a presentation about this is the technical side of things. An application is an interface. It's a bridge between the two sides, the producer and the consumer. So what does securing applications mean? Basically, if I'm protect. So if I work at the security operations center, then I would protect the organization. I would protect the assets, the servers, the workstations, the bring your own devices, the mobile phones, all that. If I'm a consultant, I would protect the customers of my organization. Obviously, I could protect the organization itself as well, but I'm not expected to do it, and I'm not getting paid to do that. I'm protecting the customers. But if I am protecting an application, I'm actually protecting both sides, because remember, it's a bridge, so there's no other way to do it. So how are applications built? Well, we could imagine some technical genius that created their own operating system, their own language, programming language that is, and they write some complex applications. But the issue with people is that we do not scale. So we need to work together to produce something really massive and at large scale and reliable. So we share. We share a lot of the code a lot of the logic that we found by trial and error. And there are a lot of teams like front-end, back-end, QA, etc., that are all working together towards this. So yeah, and obviously there is the economy side of things where we are. Yeah, obviously, the organization which we are protecting cannot operate for a long time without any revenue. So there are usually some deadlines. Not everyone is Blizzard, where they say, well, it's going to be done when it's ready. Most of the organizations have some sort of deadline. So yeah, we share the logic that we found because of the economy, but also because obviously for the reliability, the proven results, and hopefully for security. So why supply chain as an attack vector? Well, because you could target one organization and impact a lot more. Even you could impact, like it's a bit chaotic because you never know who you end up impacting, because you cannot possibly know all the clients victim supplier could have. So Sonotype, the software and security vendor, actually came up with three phases of the supply chain attacks. The first one is they call the 0 day, which is basically to find some unknown vulnerability, which even the supplier is not aware of. And there's good reason for that actually in the black market, that these types of vulnerabilities can be traded for huge prices, like maybe thousands of dollars or tens of thousands of dollars or whatever. And we all know Log4Shell. We all experienced that. And the sad news is that even 1 year or more later, some people are still downloading the vulnerable versions of it. So we have, according to Sonotype, we have the second phase, which is the actual supply chain. Malicious actors quickly realized that, well, there are some very popular packages. So if we actually compromise one of them, we can reach millions of developers and thousands of organizations. So yeah, that's pretty bad. Sounds pretty bad. Then there's this third phase, which is the corporate developer. And these phases are actually, I don't think any of them has finished. They're just like, Sonotype describes them in this way. And then there's the corporate developer, which, so in this case, there are dependency confusion attacks, which saw an explosion of hundreds of, so each year they grow exponentially. So how can we protect the applications then? There are different approaches to this. question. One is often centered on the DevOps, like you just inject different security measures into the infinite loop. There is the secure software development lifecycle, which is more of a management approach to this, and it really focuses on the whole application lifecycle. We have also the SALSA. It's pronounced SALSA, even though the acronym is not really reflecting the whole the name of the framework, but it's centered on the build. So the levels for artifacts is a great framework, and if you go to their website, they have very good explanations and great examples. But there is one issue though, and that is that using compromised dependencies is mentioned only in the 5th step. So in their point of view, the source is source code is only the code that our developers write, and that's too late, and that's the wrong way to think about it, and it's too late as the 5th step, for 2 reasons. One of them is that if you're a developer, it would be pretty obvious to you because you're writing your code, so you're building upon some shared library, and then you spend some hours doing the logic, and then you push it, and because that's where usually the scanning takes place, it's at the source control versioning system. So it's only then that you realize that, well, there's some issue with this library. So now you have to go back and rework. It may be that you need to change the dependency, and, well, there is the risk that the newer version is not backwards compatible with the previous one that you were using, etc., etc. But maybe the not so obvious problem with this is that you could be violating license without even realizing it because you never checked, and this would result in the revocation of this license. So a whole organization could spend a lot of resources on developing their product, and in the end they need to re-architect it and rework it because they relied on some, like in this case it was Nutanix, and they relied on MinIO. Probably in this case they knew that they were breaching it, but still it's a powerful example of the risk of licenses. All this brings us to trying to figure out, okay, so I'm DevSecOps engineer, or DevSecOps practitioner. So what do I need to do? Like how can I explain these things in a better way, in a more understandable way? Because you have the DevOps-centric one, the management-centric one, and the more like technical-focused one, like from the approaches. So we have. So this is what I came up with. It's actually very simple, and that's the whole point behind it. It's a function. So every developer is aware of what a function is, and this is actually the easiest way to explain what DevSecOps is. So you have the input, you have the research and development, and you have the output. And this is not necessarily a technical way, like mental model to see things, because in the input we have also the customer requirements or the product management requirements, and we also have the reference architecture. So I'm trying to make it more holistic. The other stuff, we're probably aware of most of it. So this is my idea, and in the next slides I'm going to share a bit of experience with actually implementing this. So we have the input. Okay, licenses again. So we need to understand what licenses there are, what types of them. Some are more permissive, which is great, especially Linux Foundation and Cloud Native Computing Foundation licenses, which are usually Apache 2, as the graphic shows. But increasingly, businesses are using a dual model of licensing, which means that they have an open source offer, which is sort of to hook you up and but also to like just sharing and developing together. And they have a paid version which is managed for those users who are maybe don't have the time or resources to deal with the free version. And GitHub has a pretty good assistant with that, with the permissions, limitations, and conditions. Interestingly, a lot of people are using Docker Desktop, but maybe not so many remember that they actually changed their licenses. So even though Docker Engine is free to use and it can be like used in the build server, at the actual Docker Desktop with the graphical user interface is not free. And so yeah, this is something that we should be aware of. Okay, so we chose the software that we want to use. And actually, this is very important to have great communication with your developers, because if they somehow notify you about the software that they're planning to use, then you can check it in advance and save them save them some of the risk. So we chose our software, and then we start. And then we downloaded it, and we verified the hash of the checksum of the file for the integrity. But that only tells us that the software is the one that the creator was like. We have some assurance that this is a software that we want. But it doesn't tell us much about much else. So a great example with during Log4Shell is that actually the logging library was borrowed in almost 800 other projects and seen in over 90,000 individual components. So in order to understand like what we are protecting, we really need something different, like not just the checksum. And this is, so that's why we have the software bill of materials. Actually, the practice of software composition analysis was something that existed for years, but only because of Log4Shell, a lot of people started paying attention, including regulators, and so they came up with this name. So there are three main types to create a software bill of materials. One is to just scan the static source using a tool such as Sift, which is very famous. But that wouldn't necessarily tell you which libraries are actually used during runtime. So there is also this great tool called JBOM by Contrast Security that can do just that, but it's only for Java. But probably there are going to be more such tools in the future. Okay, so we have the software. So we know what is inside the dependency that we rely on. But what do we do with this? Well, fortunately, there's a great open source project called the OWASP, so Open Web Application Security Foundation Dependency Track, which acts as a central repository of such bills of materials. It's awesome. It does it. So it has a different logic to it. You don't scan the bill of materials during the build time for vulnerabilities and fail the build if critical vulnerabilities are found, usually. But actually, what it does is that it checks. It continuously connects to the usual vulnerability databases to find to match the known vulnerabilities to the used components. So you get up-to-date information about it. The bad thing about it is that it does not export reports out of the box, and you cannot filter based on vulnerabilities in the UI, which is something that is strange that's missing, but hey, it's open free. So we have created the inventory. We have scanned it for for known vulnerabilities. Now it's time to aggregate and prioritize the vulnerabilities, and not always it's the developers or the security personnel who make that decision. And finally, we remediate them. But if you consider the number of applications that we are using, the number of multiply that by the number of dependencies there are, and multiply that by the regular updates that each of those dependencies has, it's just too much. So we need to use some automated solution, such as those which are visible. So the consumption framework is the great maturity roadmap that was originally developed by Microsoft and it was donated to the Open Software Security Foundation. Some of the first two levels we already mentioned. But what's also great about this is that we really begin to think about how, as I mentioned, so application or shared logic, shared code is some sort of a bridge or an interface between organizations. So if we are using some external application, then we really need to think about having sort of a database of the relationships with the different businesses, who the contact person is for that business, so that in case something happens, we know who to contact quickly. And then the next two levels are like very advanced, and probably if you go there, you have a very good reason and you understand what you're doing. But yeah, we're not going to go there. The Open Source Security Foundation also has a very good project called Scorecard that has different criteria for whether a public application is how secure it is actually. And it's funny because these are the same criteria that people are going to judge our work as well. So you can see the cycle there. So that was the input. And we have the research and development. We begin with the risk assessment. This is sort of a behavior tree. So you go from left to top to right and back again. So we can try to, so based on the vulnerability that we found, we may decide to fix it. If that's not possible, we try to mitigate it. If that's not possible, can we accept it? Or maybe put some, if we cannot accept it, then the only thing that we could do is to transfer the responsibility to insurers. So we have also, so to have a proper inventory of what we have, what we are protecting, we need to have reproducible BIOS. It's very important because a checksum will not tell us, will not help us much if we do not are not certain that of what we are building. So, for example, if you compile an application just a moment after you compiled it, then the checksum would be different because of the timestamps. So this is the first thing that we do, is that we just make it 0, or in Linux epoch time that would be 1970, because for historical reasons. And the second thing is that we need to download specific versions of the software that we are using. So it's not good practice to just not put anything, or just put the latest version of this software. We need to specify the exact version. And this is also good for reliability. Then we use open source. Yay, we love open source. There is actually last week a new project was announced, which is called Chain Loop, which is great if you have if you are responsible for multiple different build source control versioning systems and build servers, because it works with all of them and it makes the work allegedly. I cannot say because it's very early in development, but that's the whole point, is that it makes working between the developers and the security, so the application security personnel, easier. And it also integrates with dependency track, which is great. Feedback loops. So it's not enough to just use some kind of technology. Communication is very important, and so we need to somehow integrate the technology and the processes and the communication so that there's self-generating and self-sustaining loops. For developers, that would be self-service static analysis, dynamic analysis part of the build process. And then together maybe we review the statistics together with the product owners, managers, whatever, and the developer team leads, we prioritize. That's for first-party proprietary code, not for the open source. And then we proceed with the mitigation. And as time progresses and people get into the habit of doing this, it's becoming self-sustaining. So during the research and development, there is quality assurance, but why not? It's easy to actually work together with QAs to build to integrate the security assurance inside. So here is an example of Postman, which is very famous for API, this is the GitHub issue that is still open, even though it's from 2021, about integrating it with Open Web Applications Security Foundation Z-Attack proxy. And we love open source because not only because it's free, but because there's great collaboration between people and a lot of knowledge and experience being shared. So this is a great example. Okay, so we're to the so we've done the research and development. So maybe someone's thinking, okay, if I've shifted left, I've done all that I can. I've scanning for vulnerabilities, misconfigurations, compliance violations. So I have prevented threats. Well, not exactly. So in this case, organizational security is wiser, let's say, and has more experience, so we can borrow from the cybersecurity framework. So yeah, we need to also detect and respond to threats. It's not enough to try to block everything, because it's probably not possible as well. Really, this is very complicated because there are just so many pieces of this, and they're all interacting with each other. But just to give an example, so on the left column, you can see the code, container, cluster, and compute or cloud, which is the 4 C's as they are known. This is and on the right side, it's let's say my interpretation of what the different aspects of each of those is. And so they're the same, but they're just applies to each one of them. So for storage, for example, obviously the program itself stores its data on the random access memory, and maybe even in the in-memory database. The containers are storing in environmental variables as well as volume mounts. The cluster is storing data on the config maps, secrets, and volume claims, persistent volume claims. And then the compute obviously has the databases and storage drives. So this is like just on the one level, and there are many levels, and they're all interacting with each other. So this is very broad topic, but just wanted to give an example. So this is actually from Red Hat. They donated their incident, so their product security team donated their process to the FIRST organization, it's called. And it's great. I recommend everyone to check it. I'm just included it here. So there's also a lot of innovation happening here with sandboxed containers or container runtimes. And actually, if you have a really sensitive component of your application, such as a database, you can just for the node where the database is, you can select a different runtime environment, and just for that node, and Kubernetes is going to take care of that. So traditionally there is the intrusion detection prevention systems. There is the web application firewalls, of which again you can see. I recommend the Cloud Native Computing Foundation project called QRefense. And then like the more modern approach where this is all going, it's runtime application self-protection, which is great. Unfortunately, there is no open source project for that. There used to be some years ago, I think 5, but it got abandoned. So interesting enough, maybe some of you went to the workshop for Contrast Security Assess, which has that included. So the future is confidential, so-called confidential computing. We have the homomorphic encryption, which is basically magic, because you could never have to decipher data. Like it can always stay in ciphertext, encrypted, and you can still compute with it, which is crazy stuff. And then there is the trusted execution environments, which are basically part of the central processing units, which are safe. They cannot be breached. So this would really make our work easier and protect our customers a lot. So what are the takeaways? As I hope this illustrates, it's and many in the industry are now saying that shifting left is not enough, because we cannot block every threat. Sooner or later, the practice matures, such as just like security, so enterprise or information security matured. So we need to shift smart or whatever. Like we need to cover the entire process. Yeah, that's it. Any questions? Okay, thank you very much.